Hey everybody, my name is Josh and I am a principal engineer with Milestone, and today I want to walk through a fun project, or at least it was fun for me. I'm doing a recording this time due to a scheduling conflict. 2 a.m. is a tad early for me to do a presentation local time, and at 10 a.m. tomorrow morning, I'll be in the middle of a group session with some of my colleagues here in Lake Oswego. So again, my name is Josh Hendricks. I'm part of our principal engineering team. And today I want to show you a repository on GitHub that should be published by the time that you see this. And yeah, let's get into it. So the idea of this repository is to do automated testing of milestone systems. So more and more often, I find myself communicating with customers who have an expectation that all of the software that they deploy and manage in their environment can be done in a scalable way. And with some elements of CI/CD or continuous integration, continuous deployment, and or infrastructure as code, and I wrote IAS here. I meant to say IAC, infrastructure as code. So it feels like a bit of buzzword bingo, but it's becoming more and more common that medium to large customer environments, enterprise environments are implementing sort of like cloud ready, cloud native infrastructure as code and system monitoring. Um, and we've been building and using the Milestone PS Tools PowerShell module for just over 3 years now. And I've found it to be an excellent tool for rapidly building tools for reporting and bulk configuration. And this repository is intended to be just an example, one opinionated way that you might do sort of infrastructure as code or some style of sort of configuration monitoring. So there's different concepts for how you might monitor configuration in of an application in a large environment, and concepts like desired state configuration and tools like Ansible and Chef and Puppet and things like that. What I'm demonstrating here is sort of a read-only method to just keep an eye on the state of a Milestone VMS using free or fairly inexpensive tools from GitHub and PowerShell modules. So uh, you might implement something similar to this to monitor the health of the VMS. So when cameras are online or offline, if video retention expectations aren't met, or if certain components of the VMS, so a mobile server or your event server or different recording servers, are experiencing issues with availability. And you can also define sort of expectations of what the configuration of the VMS should look like. For example, all cameras should be assigned to a storage configuration that has 30 days, that's configured to retain video for 30 days. Or all cameras should have two streams, one for recording and a lower resolution stream for live. So there's different ways that you might implement this. And in this repo, um, like I said, this is an opinionated example of one way you might do this, one way you might automate your monitoring and reporting. So alternatives might include something as simple as setting up a scheduled task in Windows, or something more complex might involve building a Windows service-based application or a Milestone MIP plugin that could have like a background plugin element to it, and maybe an administrative plugin in the management client for manipulating the configuration of the integration. Um, Myself, I spend a lot of time in PowerShell as I work on the Milestone PS Tools PowerShell module, um, and I see it as a really powerful tool for both developers and for system administrators. I think it has a much lower barrier of entry compared to something like C# or Python or Java and other languages. It's broadly used by Windows system administrators, and it's more and more often used in like DevOps scenarios and by folks that are working on both Linux and Windows environments. So let me talk a little bit about the tools that are used in this repository, and then we'll go into um, we'll kind of dig into the module and show you how it works. So um, the first tool, obviously GitHub. We're using GitHub for source control. The script execution. So we're using PowerShell Scripts. We're executing those using GitHub Actions. Right now, the GitHub action is set up to run on demand. So I'll manually trigger it from the GitHub website. But you can trigger a GitHub action based on lots of different things, including even a cron job. So if you want to run it every 5 minutes or once a day, you can schedule the GitHub action to run whenever you like. We're using, in this case, I'm using Docker to run the GitHub actions. So I'm using a self-hosted runner, which means the application that is receiving the job to run this the script this repository is presenting, that's running actually on my laptop that I'm presenting with. And you can use either a GitHub hosted runner or you can use a self-hosted runner. It's up to you and sort of your what your requirements are in your environment. So you might use a self-hosted runner if the VMS that you're monitoring does not have internet access set up, so you can't log in from somewhere out on the internet. And in this case, I could, with a self-hosted runner, if I had a VMS that didn't have that had internet access, but I wasn't doing port forwarding to access it from the internet, a self-hosted runner would be able to execute against that VMS from within the network and report the results back to GitHub. PowerShell is our shell of choice here. Pester is a PowerShell module for test automation. That's a really great test automation framework for PowerShell. Milestone PS Tools. It's a PowerShell module that is essentially a wrapper around our MIP SDK. So it's a .NET framework-based PowerShell module, and I'm using that for communicating with Milestone and logging in, retrieving configuration and status information. And then to present the results, I'm using a tool called extent reports. So there's a command line interface to take the NUnit XML test results from anything that produces NUnit based XML test automation results. Extent reports can generate a website, a static website from that XML file. So I'm using that to generate a website, and then I'm using mkdocs. I'm actually using a very small portion of mkdocs, or makedocs, depending on how you like to say it. And I'm using that to deploy that static website to GitHub pages, so that it's when the Pester tests are finished running, the results are updated on a publicly available website automatically. And I'll come back to the things I would change given the time. Let's look at the contents of the repository. I think first we'll start with what the results look like. So at the top here, I have a badge showing that the tests are failing. And if I click that badge, it's going to take me to this extent framework-based site that's showing the sort of beautified results of the NUnit test results. Now the formatting, I'm not necessarily really happy with the formatting of the extent report here. There might be some options that I can tweak to just make it a little bit cleaner. But if we look at the results, we have our dashboard showing, there we go, the tests, the steps that were run. So 600 steps passed, 66 failed, and we can go through here, we can filter for just the failed tests, and we can see that there's some cameras that don't have good motion detection settings. So that's a test that was defined in the Pester as a Pester test. And so we can see here that we expected that we wouldn't be doing motion detection on all frames, but for at least this baseball stadium camera, for some reason it's set up to do motion detection on all frames. That can potentially have impacts on CPU usage on your recording server. And so it's not a super common configuration, so it might be something to look at. And then we can scroll through. We won't go through all the different test results here, but the idea is that you can quickly see which tests are failing. You can define what your tests are, and view them in a nice web-based interface. All right. So here is the project in VS Code. I spend a lot of time when I'm working on pure PowerShell or like a mix of PowerShell and YAML or something. I'll spend most of my time in Visual Studio Code rather than Visual Studio proper. I think Visual Studio Code has just got a much better interface for working in PowerShell than Visual Studio. And I'm going to increase the size of this just a little bit. There we go. And let's just go from the top down. So at the top, we have our GitHub Workflows folder. And this is the folder that you would put any GitHub Actions workflows. So this is your pipeline file that says what steps you're going to execute. And right here, I have it defined to run on workflow dispatch, which is, if we go to our Actions tab in GitHub and select our workflow, I can click here and run the workflow. And I can choose, if I have multiple branches, I can choose which branch to run it from. But this is where I can run it. And you can see I have a test running right now. I may not be able to show a full test run in this recording just because the Wi-Fi at the hotel here is suddenly a bit slower here at 11 o'clock at night for some reason. So this is just one way that you could have this test run. If you want it to run automatically, you could set up a schedule using the cron job notation. So GitHub supports the schedule node here with cron job notation. You can also run on anytime there's a push to the repository or a pull request, and there's different ways to trigger your pipelines. And here I just have one job. I think it's just the one. And it runs on self-hosted. So that just means it's going to run on one of our runners that we have added to our repository. So this runner is running in a Docker container on my laptop here. I wouldn't necessarily do that in production, so it's just being done here as an example, but you could have your GitHub runners running in a container that is defined for your specific purpose and in your environment, or you can replace this self-hosted with Windows latest, and then the test will be executed on a GitHub hosted runner. So if the system that you're running tests against is accessible from over the internet, then you could use a GitHub hosted runner. And depending on how many minutes that you run per month, that could even be free. It just depends on how you're using it and how heavily it's being used. And then for our steps, we're checking out the repository, and then we're running our Pester tests. And the rest of this section, I won't step through it line by line, but it's effectively setting up a Pester test and then running it. And at the end, we're going to generate our website from the results and then use makedocs to deploy it. And if the tests fail, we're going to exit with a non-zero exit code to make sure that that GitHub recognizes it as a failure. All right. Now the next folder here, I have a bin folder that has the extent reports CLI, the command line interface. So I went to the repository for that tool and built it and dropped the executables into, or the assemblies into this folder. And now it's just a part of the repository. So when the GitHub action runs, this bin folder is included when the project or the repository is checked out. And then that extent reports utility is made available. Okay, so now we have this docs folder. This is not part of the repository. It's not checked in. You can see in Visual Studio Code that it's sort of grayed out here. So this is an artifact of running the Pester tests and then the extent.exe utility that generates the website. So the HTML file gets dropped into this docs folder, and then we're pushing the contents of this docs folder to GitHub using makedocs. The runner, this is the Docker Compose or the Docker file and a Docker Compose that you could use as for reference on how you might use Docker to or build a Docker image to host your runner. So I won't go into detail on the contents of everything here. I have a fairly simple Docker file that is saying we're going to have a GitHub URL and a GitHub token, and then our Docker Compose file is going to provide those arguments from a .env environment variable file and run our runner. So on my machine, I can go into this folder and do Docker Compose up, and that's what I've done here. So in this tab, you can see it's a little misformatted here, but you can see what it looks like when I start this Docker container and it starts our self-hosted runner. And then it just sits here and it listens for commands to run jobs. Okay. In the PowerShell scripts here, there's the prepare, which is going through and preparing our Docker image with making sure that Python and mkdocs is installed. The PowerShell module, Milestone PS tools, and Pester are available. Git is available. And then the run script is kicking off the GitHub hosted or the self-hosted runner. So it's just running that run CMD after making sure that we have the necessary environment variables defined. And those environment variables are defined using secrets in GitHub. So in the repository, there are secrets defined, which I can show you here. If we go to secrets and actions, so here's a set of secrets that we have defined where the username and password and the server address are passed into our workflow, and then eventually into the Pester test automation. All right. Now this site folder, again, this is an artifact of just running the test automation. So at the end of the Pester tests, we are generating a website, which is this index.html. And then when we run makedocs, it is producing this site folder that we don't need at all. So that doesn't get checked into the repository. And then before we take a look at the tests, the rest we have here is a simple git ignore file. a basic make docs file that defines where the GitHub pages content is going to go. And then we have our README, and then a list of URLs that are used in one of our tests to verify certificates and if they're valid or not. And finally, let's take a look at the tests. So if I jump into the Milestone Tests here, again, I won't go line by line. Have a look at the Pester documentation. It's really good. If you plan on doing anything in PowerShell and doing any sort of testing, Pester is where it's at. So initially, we're accepting some parameters for our test. And then before we discover the tests that are defined in this file, we're going to go ahead and log in to the management server. So using the connection parameters that are defined in the GitHub Actions secrets. And we're going to just gather some basic information real quick. So get item state is going to get the device state information from the event server. We're going to get a list of registered services, and then later on we'll check to see if those services are available. And then down here we have some, this is where the tests are defined. So we have a describe block that says these are Milestone BMS tests for a specific address. And then, yeah, so we have a test here that says it has cameras. So it does a call to get VMS camera, and it should return more than 0 cameras. And if it returns 0 cameras, that's a problem. We want the test to fail. Another one is the camera is responding, and this is using the what does Pester call it? I think it's data-driven tests. So we're passing in a list of test cases for this particular test, and for every device in this item states collection, we're going to go ahead and make sure that the state of that camera is responding or communication stopped. If it's not responding or stopped or something like that, then we want this test to fail. And the rest of the tests are along those lines. So the idea is that these are sort of common sense tests that we should expect to ideally always pass. And if they fail, we want to know about it. Let's see if there's anything else in here. Yeah, so and then at the end, the after all block is going to get called, and it's simply going to disconnect from the management server to make sure that we cleanly disconnect when we're done. And so after all these tests run, the results are produced in a NUnit XML format. And this is what the extent reports utility, the command line interface, looks at and generates our web-based results in. So if we go back to our actions, let's see if that job has finished running. All right, so that job is definitely hanging. They usually only take a couple of minutes at most. So I'll take a look at a job that ran previously. And this is what it looks like in the GitHub web interface on a failed test. So we can click here and see the details from Pester. So all of this content is produced by the Pester testing framework. And GitHub has gone ahead and pulled out some annotations. So they've seen, I guess they've looked at the test results and said there's some failures here. It says error, and so it's highlighting those errors for us and giving us a quick preview of all the failures that are there. If this test had passed, then in our in the README here, this badge would be green and it would say passed or passing. In this case, the last test failed, and the URL that we have set up is going to our GitHub pages. So this page is actually hosted by GitHub. It's on my private domain, but it's hosted on GitHub pages. And yeah, so we have the a dashboard. I think, is this the one? I forget which one is. There we go. So this is the extent framework dashboard showing the test results and sort of breaking things down by pass or fail. And they differentiate between tests and steps. Um, Again, the formatting, it's not my favorite. I think there's some things that I'd like to see different, and there might be parameters in the extent reports CLI to change that. But then we can go into detail and drive through all of the test results and dig into specifically the failures, and then we know what needs to be addressed. All right, let me go back to our README here and talk about what I would change given the time. In summary, I think something like this should evolve with the environment. And also the product over time. So in that sense, I don't think there's an end to the things that I would change over time. But there are a few things that I would absolutely change right away if I had the time. So the first thing I would change is to move all of the PowerShell commands out of the GitHub Actions workflow YAML file and into their own PowerShell files, and use something like the Saki build automation tool. So Saki is a really great task runner type tool for PowerShell, and so that's also what we use in the Milestone PS Tools module for building the project. And then I would expand on the sort of common sense tests and validate more assumptions. So for example, if a camera is in a 30-day storage configuration, it should also have video going back close to 30 days. Maybe not exactly 30 days, but 29 probably, and maybe 90% or 95% of the retention. There's probably some common sense or standard that you could apply there. And then if a camera is recording on motion, it probably should have observed a motion event in the last 24 hours. So it might check for something like that. There's a lot of different tests that you could add that you would expect to pretty much always pass. Those are the kind of things that I would build into a tool like this. And then finally, depending on the environment and how the VMS is being used, I might consider generating alarms in the smart client on a test failure. So instead of relying entirely on GitHub or a reporting page like this, I might have the tests themselves at the end generate an alarm that is visible to the system administrators, so that if they're already in Smart Client on a regular basis, it's going to be front and center in the Milestone interface that they're already using, and then they can take action on it from there. Add notes to the alarm in Smart Client as they deal with the situation. So, yeah. And with that, that concludes my my session. I thank you very much for your time, and we'll go ahead and share links to the repository at the end of the Dev Connect. And yeah, I welcome any comments and feedback. And hopefully, I'll see you in the chat, at least at the first session at 2 a.m. local time. Thank you so much.